This video, we're going to talk about a static keyword in C++. It is one of those keywords that can have different meanings depending on the context that you're using. So without further ado, let's take a look at some examples. Right now I have a main.cpp which has a main function and returns 0. So imagine I have a print function right here, and this print function does nothing but it prints out a value for me. So right now Clang is complaining about this value because I haven't defined it. So if I say value equals 0, I want to do a little twist here. I want to say in the end value plus plus, and I want to use that function in my main function. So the first time I use this, the value is going to be 0, it's going to print 0, and then value is going to be 1. So the question is, if I run this function again, will I see 1 printed the second time, or will it be again 0? Let's take a look at that. Oh, by mistake I made that. So if I say g++ main.cpp, and if I run my program, then you see 2 zeros. And it's kind of obvious because once we are out of scope of this print function, this means that value is destroyed and we no longer have access to that variable anymore. It's gone. It's gone with the wind. And however, if I add the keyword static right there, let's see what effect does that one has. If I run it, then I see value 1. So what does it mean if you mark a variable as a static inside a local scope, such as print function? It means that the static keyword doesn't affect the scope of this variable. So once you're out of a scope, you no longer have access to that value in your program, but the lifetime of this thing is affected. And it means that the lifetime of value is the same as the lifetime of our program. So this means as long as our program is alive, there is somewhere in the memory allocated for value, and each time I access that function, I can have access to that value. So this is, let's say, the first context. Where else can I use this static keyword? I can also use it when I define some data members or member functions in a class. So let's say I have a class called particle. I want to do some particle simulation. So I want to have a bunch of particles in a simulation medium. Then I want to see how they interact with each other, or what is their dynamics when I put a force field around them, and see their movement. But one property that is very important to me is to know how many particles at each instance of time I have in my simulation. So I can achieve that by saying std size t particle count, and I want to mark this as static. So let's see what effect this one has. So now I say in my constructor that each time I inject a particle, you need to say particle count plus plus. And I also need to take care of dying particles. So I need to have a destructor to take care of that thing. So each time a particle is dead, so we have this thing. And then I go in my main function, I create some particles. So for example, particle P1, I copied that, pasted it a bunch of times. And I say particle number 2, particle number 3. And all I want to do is to see we have particle count. And then I can go to the next line to make it better. Particles in our simulation. And then I say inline. And take a look at this. Right now the Clang is complaining about these things. So let's take a look at this, because I have marked everything. Everything is private by default. I mark it as public. Now Clang is not complaining anymore. And let's take a look at also this thing. So just pay attention how I access this particle count. I used class name and then scope operator and then particle count. I can also access particle count through the instances of that class through P1, But I want to show you something nice. I want to say ampersand. I want the memory address of p1.particleCount. And what I want to do is to copy that line. And then I want to say p2. So I'm accessing particle count once through p1 and once through p2. I want to see the memory location of that thing. Okay, one thing I forget, of course, is that I forgot to initialize this thing. So I need to have like 0 particles once I start my simulation. If I say G++ and I run it, we have 3 particles in our simulation, and now you see that both of these locations are the same. So what does it mean if you use a static keyword when you define a data member in a class? It means that this thing is shared among all the instances of class that you have. You see that here, both of them had the same memory location. So it is a property, in other words, this particle count is a property of the class itself. It is not a property of individual instances of that class. Of course, you're not only bound to use a static keyword when you're defining some variables, you can also mark your functions as a static. So let's say I have void, for example, cloud status, and that is gonna just print for me that cloud is active. Like cloud is active. And what does it mean in that case? It means that I can have access to that member function without asking a instance of a class. So I can say again with the scope operator, I can say cloud status. And then when I compile this and run it, you see that it says cloud is active. So that is if you mark a member function as a static. What else can I do with a static? I can use also a static keyword with a global variable to show that I can, for example, make a file.cpp. And let's say in this file I have a global variable, which has the value of 10. And I urgently need to use this variable in my main.cpp. So I need to say std cout and then my global var equals to global var std end line. And right now Clang is complaining about global var not being defined. So of course I can do this trick with the extern keyword. I can promise Clang that somewhere in my .cpp files, this global var is going to get defined. So if I do that, and then if I say g++ main.cpp, this time I need to also add file.cpp. And it compiles, and you see that I have access to my global variable. However, if I go into my file.cpp and I mark this variable as a static, let's see if it works. I compile this thing and I get a linker error. It says global variable symbol is not defined inside main. So what does it mean if you mark a global variable as a static? It means that you only have visibility or you only have access to this variable once you are inside this translation unit, and that is file.cpp. So you no longer can directly use global variable in any other .cpp file with that extern trick that I showed you a second before. But I can still have access to this variable indirectly. I can say, for example, I have a access function, and this access function is going to give me just return global variable. If I do that and I go to my main, I need to, of course, add this access function here. And instead of accessing global variable directly, I can say access. And if I do that, I compile it and then I run it, you see that I still have again access to this. But it is not direct. If I want to change that variable, I can copy this thing and I can say I have a void function, and then I can call it as edit. and it gets a constant reference, for example, called value. And all it does is basically it says global var equals to value. So now if I go to my main function, of course, I need to add that thing here. So I need to say void, this is edit, and it gets a constant reference. And after that, I need to edit my variable. So it had value of 10. Now I can change the value to be 3, for example, and then I can use the same print function or access function to print it. So if I compile this and I run it, you see that I can also have edit access to that global variable. So there we go. We, as a summary, we have seen 3 different examples of using static keyword. The first one was using static keyword to define a variable in a local scope. The effect was the variable doesn't affect, the static keyword doesn't affect the scope of that variable, but it does increase the lifetime of that variable. You can also use it for defining data members and member functions of a class. And what it means for data members, it means that this is a property of the class itself. You can have access to that without needing any instance of that class. You can directly name the class, use the scope operator, then use that variable. Same way for these methods. These methods also can be called without any need to have an instance of a class. And then lastly, we talked about using static keyword with global variables. And the effect that one has is that it has visibility inside that specific translation unit that you define the variable inside. And if you want to use that variable in other translation units or in other .cpp files, you have to have indirect access through some functions. So this extern trick doesn't work on when you mark a global variable as a static. So that's it for today, and I hope you learned something from this video.